In this video we'll continue implicit differentiation exercises, and we'll look at number 5 now. We have x cubed minus xy plus y squared equals 7. And we begin by taking the derivative of both sides with respect to x. And on the left side we'll get 3x squared. Then we have minus a product. You have to watch out for this. We're going to need to use the product rule with implicit differentiation. So first of all I'm going to write minus and then put the results in parentheses and worry about the signs later on. So I have the first times the derivative of the second, giving me x y prime, then plus the second times the derivative of the first, which is just 1. So the derivative of x is just 1, and we end up with xy prime plus y. Now this is kind of a famous product rule in implicit differentiation. You're going to see this often. The derivative of xy, and that's xy prime plus y. But because we're subtracting that, I put it all in parentheses, and we'll simplify it in a minute. Following this, we have the derivative of y squared, which is simply 2y to the first times y prime. And not forgetting that the derivative of a constant on the right side is always 0. So when I apply the negative sign, I'm going to get 3x squared minus xy prime minus y plus 2y y prime, and that's equal to 0. Alright, so we did the calculus. We took the derivative of both sides with respect to x. We simplified. Next, we're going to collect all of the y prime terms on one side. So I'll write it with the positive. I have 2 of those terms, and I'll write it with the positive 2y y prime first, then minus xy prime. And moving the remaining terms to the right side, I'll begin with the negative terms on the left, so that'll be y. It'll go across as positive y, and then minus 3x squared. Now I want to factor out the y prime, so I've isolated the y prime terms on the left, and I want to factor out a y prime from that, giving me y prime times the quantity 2y minus x is equal to y minus 3x squared. Now when I divide both sides by 2y minus x, I end up with simply y prime is equal to y minus 3x squared divided by 2y minus x. Now you could get something that's a little bit different than that, but equivalent, just because of the way you deal with the negative signs in there. And I've done them in a particular way. So if you get an answer that's slightly different than that, you might want to consider whether or not it's the same but different because of the signs involved, or the way the signs are treated. We'll go on to problem number 7. In problem number 7, we have x cubed y cubed minus y is equal to x. So once again, the first thing that we do is take the derivative with respect to x on both sides. Now when we go about taking the derivative on the left side, we see that we have a product rule there. So it'll be the first times the derivative of the second, or x cubed times 3y squared y prime. Whenever we take the derivative of something with a y in it, when we're taking that with respect to x, then we always have to multiply by the y prime. So again, this is a product rule. We have the first times the derivative of the second plus the second times the derivative of the first. Sorry, the second is just y cubed. Times the derivative of the first is going to be 3x squared. So that takes care of the derivative of x cubed y cubed using the product rule. Next we have the derivative of y, which is just dy dx, or y prime. And on the right side, the derivative of x with respect to x is 1. So we're going to simplify and collect our y prime terms on the left, moving the others to the right. So the first we'll write as 3x cubed y squared y prime, then minus y prime, and we'll subtract 3x squared y cubed from both sides. We'll factor out the y prime on the left, and we end up with y prime times 3x cubed y squared minus 1 is equal to 1 minus 3x squared y cubed. Divide both sides by 3x cubed y squared minus 1, and in the end we have y prime is equal to 1 minus 3x squared y cubed divided by 3x cubed y squared minus 1, and that does it for this set.